Hey guys, welcome back to Awesome Everyday, where today we'll be making a boost converter. I know it is going to be like the Jewel Thief, but still, it's gonna be much better. I think it's called it's called the Buck Boost Converter, I think so. And look at this fidget spinner. So yeah, let's get right to it. First, I'll show you the diagram. Then I'll show you the making procedure, and after that I'll show you the making. So this is the diagram. 9-volt battery, coil, coil or inductor, whichever you like it, a switch, a diode, and a capacitor. The value of the capacitor, the number of turns in the coil, will determine how much boost do you want to get. So yeah, I'll give you time to copy this, and yeah, that's just my math. Yeah, so I'm giving you 5 seconds. 1, 2, 3, 4, 5. Hope you have copied by now. Here are all the components. Focus. So the coil will have 200 turns. The diode code is IN4007, and the capacitor value is, I think, 1000. I think it's called picofarads and 16 volts. Here I know I'm using less volt capacitor, but look at how many farads it's got. Yeah, I even have a bigger AC one that I'll just show you. So here's the first one that I have. This is an AC capacitor that I used in the video of how to staple, and as you can see, 440 volts AC, 50 hertz. Okay, pretty good. But I have even a bigger one that my kind friend rented to me, and it's like huge. You're gonna freak out when you see this. This boy, look at this. That's my math notebook, don't worry. So this is the huge capacitor. Yeah, it's actually almost equal to or bigger than my hand. It has 4 terminals. C common. I don't know what Herm stands for, but I know the fan. And this was taken out from an AC. Not the power line AC, like the AC. You know what I mean. The cooling fan thing, Yeah, this is comparatively like huge. I think now you must get how huge it is. So yeah, we are not going to be using this, but we are going to be using this tiny little capacitor. This tiny guy over here, 16 volt and 1000 picofarads. This is the negative side. This is the positive. And we are going to be soldering everything. And for the coil, I've just used a transformer. It's secondary winding. Sorry, not the secondary, the primary winding. I'll just show you. If you guys remember this project, this is the transformer I'm going to be using, but not this output, but the input. It has about 200 over here, and I think 250 or 300 on this side. I know this has much more, but as you can see, it is soldered. Everything is in place, soldered. So yeah, I cannot turn it out. So I'm just going to have to use this side, which is about 200 turns. So we got everything. I'll be back when it's soldered. Guys, the circuit has been made, and I know I said that twice. Yeah. So the circuit has been made thrice. The wires going to the switch. Yeah, this is a temporary switch. Diode, capacitor, wire, and at the end of the switch, input and input. Yeah. Instead of using this, you could use a much smaller one. This is, let me see. Come on, camera. Yes. This is 100 picofarads and 16 volts. This is also 13 volts. Damn it. I'll be back when I have found, 400 volts, one capacitor. Oh wait, I have it right here. Yeah, these are 400 volt capacitors each. 1, 2, 3. Resistor, bridge rectifier, I don't know, I think I crashed this resistor and a transformer. Yeah, this is the charging circuit. A few ICs and SMDs over there. And I cut the rest of the board. Yeah, I was making, I was attaching wire over here, and when I actually plugged it in, I just shorted it from here, which caused this resistor to blow up, as you can see here. Because if it worked, I could have get pulsating DC/AC voltage out of this side of the transformer. This is the high voltage side, but go to hell. This is my soldering kit. Yeah, you get what I mean. Now the working. Okay, let's just sit down. So I'll explain it in paper later. So let's imagine the voltage is, the switch is closed like this. Come on. Think the switch is closed. So the voltage flows into the inductor. The inductor creates a magnetic field, become an electromagnet, while the switch is on. And as soon as the switch opens, this inductor will now discharge through the battery, adding extra voltage to 9 volt, making something like 10 or 12 volts. Then the diode goes through the half rectifying gate, then stored in the capacitor as 12 volts. Focus. Come on. There we go. And then it will store here. Then the switches again will be closed, creating a magnetic field, and then when you open it again, more 12 volts will be stored in here. But the capacitor will not discharge because of this diode. Except for the diode, you can use an LED, but that would be like wasting it, because most of the energy will be consumed by the LED to make it low. And if you didn't know, LED stands for light emitting diode. Okay, as now you know how it works, let's give it a... Okay guys, testing, and I can't test it because I need another person to pull the goddamn switch. So I won't be testing it, but I will make a video of it in the future, maybe. But till then, try making this. I want to see if yours works. But I am sure that mine will work because I have not tested it yet. But off the camera, I've tested like a million times, and it sometimes even sparked when I shorted it with just a single wire of this capacitor. So that means it works. So go ahead, build this for yourself. If you don't have a transformer, just get some magnet wire. Do about 100 turns. 100 turns should be enough. But yeah, 100 to 200 turns, done. So this is the circuit. Just one look again. And these are the inputs. So as always, like, subscribe, and don't forget to comment. Should I put a Minecraft video next or something else? Till then, goodbye.